Okay, so this is the lesson we're doing, but I want to take a brief moment to talk about what's going to be on the quiz. And so if you actually look in the table of contents, I already wrote the three things there, right? I wrote it's 6.2, solving similar triangles. So that includes, here, I'll like type it out here, writing a statement. You know, like triangle ABC is similar to triangle DEF, right? It's knowing which, like if I say ABC, then you got to make sure that DEF correspond to ABC, right? It's labeling triangles, right? So you know how to label the angles and the sides, and um, and if I have two, so the level 3 question, the two triangles are going to be oriented the same way. So it's like the bottom angle is the same as the bottom angle, the top is the same as the top. But for the level 4 question, the triangles might be rotated or they might be on top of each other, right? So you have to figure out which angles are identical. Then you will have to solve for missing side. So very straightforward. It's like literally a homework question. Okay. Does that make sense for similar triangles? Next, SOHCAHTOA. So for this one, what you're going to do for the level 3 question, there are going to be two questions. It's going to be find angle and find side. So two separate triangles. One of them, it'll say find angle whatever. The second one will say find angle whatever. Got it? For the level 4 question, level 3, level 4 will be solve a right triangle. So it's basically 6.6, right? Because when you have to solve a right triangle, you have to do SOHCAHTOA and TOA, right? So if I see that you know how to choose which one you're supposed to use, SOHCAHTOA, TOA, if I see that, like in that solving the triangle, you're going to have to find an angle and you're going to have to find a side. So everything is, all those skills are covered in one question. Make sense? Okay. So this 6.6 is covered, like this number 2 and number 3 are one question. And then the last thing you're going to have on the quiz, here, I'm going to do this. Just so you see, there's 3 questions. Third question is going to be a communication question. So in the first homework, you had some communication questions. We've talked about some questions like, why is sine of 90 equal to 1? Or why is tan of 45 equal to 1? Right? So you might not know the answer, but what you're going to do with that communication question, you're definitely going to draw a triangle. Right? I'm like, if I'm saying tan of 45, then I'm drawing a right triangle that has a 90-degree angle, a 45-degree angle, and guess what? A 45-degree angle. So when I draw it, I'm like, oh, it's isosceles. And then I might put some numbers on that triangle and see what I get for tan. Or for sine of 90, I might put some numbers into my triangle and see what I get. Right? So you're going to have to sort of, it's like a thinking question and a communication question. So you will communicate with a diagram, with math words, maybe with an equation, right? There's different ways to communicate your understanding. Okay? So, do you want some examples of communication questions? Probably. Examples of communication questions. This is straight from homework. Right, and you're not going to, so if there's a question that says, are all isosceles triangles similar? You can't just say yes. You're going to draw a picture. You are going to use some numbers. You're going to show. If you say yes, you have to show me a few examples. If you say no, you got to show me a few examples. Okay? So here are some examples. Okay? This is in the document called Table of Contents, right? So you have that link. Okay? So there will be a communication question, solving a right triangle question, and solving similar triangle question. Got it? Today at lunch, I'm doing a tutorial on SOHCAHTOA. So I have a new printout that's like, I call it SOHCAHTOA 101, meaning like what, like the main things you need to know for SOHCAHTOA. Okay? So if you're still a bit stuck on how to use SOHCAHTOA, which one to use when, how to find an angle versus a side, today at lunch will be helpful. Okay. So let's get back to the lesson. I didn't make any notes here. Okay. So before we start on some of these questions, so what the idea today is that we're solving problems with two right triangles stuck together. Yes. Yes. And did you do your homework? Yeah. Okay, thanks. So in all of these questions for 6.7, it's all about having two triangles. They're both right triangles, and they both share, they either share one side or they share one angle. So with these triangles, you can see they both share the height. Okay? So the goal is we always want to find what both triangles share. An angle, a side. And we're going to start by actually going back to page 10 and doing example 1 on page 10. Okay. Go to example 1 on page 10. Now, I forgot to ask, does everyone have a calculator out? If not, get it. If you need to borrow one from me, please come on up. What are you checking about your calculator? What mode is it in? Degrees. Excellent. Here you go. Is it in degrees? Yeah. Okay. So let's look at this example. We've got Example 1, we are asked, solve for x and then y to the nearest tenth. Okay, solve for x and then y to the nearest tenth. Folks, nearest tenth of a meter, how many decimals is that? 1, because there is no oneth, right? We never say to the nearest oneth. So tenth is the first decimal. Okay, so we've got this triangle. Let's start off by labeling it just so we know how to talk about this triangle. Let's say, I'm just going to make up letters. Actually, Maya, give me a letter. So creative. Hugo, give me a letter. No! You're fired. Alina, give me a letter. Ooh. Caleb, give me a letter. No, you're fired. Alex, give me a letter. Totally fired. Cruz, give me a letter. Y. Thank you. Woohoo! Actually, I'm not going to use it just because we have a Y there, but I appreciate that. Ivy, give me a letter. Yeah. And one more, Serafina. You can do it. Absolutely. So that little vertex there is S. We're so used to using ABC or XYZ. I want us to be comfortable with random variables. All right. So first, let's look at this triangle and let's understand and let's make a little game plan. So what I'd like you to do is talk to your person or look at it by yourself and think of the strategy. What am I going to find first? What am I going to find second? What do I have to do to find it? Okay? So take a moment. Yeah. Подумай, чи ти перше X будеш знаходити, чи перше Y? Окей, подивися собі. Тільки є одна відповідь. All right, folks, which one do we solve for first? There's only one correct answer, actually. What is it, Quincy? Yeah. Why do we choose? Who else thought X is what we're going to start with? Great. I'm curious why, Ivy, you thought we're going to start with X.
Because SDQ is triangle, doesn't have any side length.
Great. So she's recognized that in SDQ, there isn't enough information. How many pieces, show me with your fingers, how many pieces of information do we have in triangle SDQ? With your fingers. I disagree with some of you. Yeah, it's not one. Okay, because, right, what can we assume very fairly? This is a 90-degree angle because these two 90-degree angles create a straight line, meaning they create 180 degrees. So you can assume that. It's not assumption, it's a deduction. I only have two pieces of information, not enough, and I need a side length. Where can I get that side length from? Alexi, where do I find it from?
From finding X.
Beautiful. So, Caleb, in which triangle do I start?
ADS.
Yeah, I start in ADS. So that's the strategy. That's the game plan. Put the telephone away for these things. But like in your bag away. Okay? And take the earbud out, please. Anyone else with earbuds? Bitte hi. You start, so the game plan is, I'm going to type this. Start in triangle with 3 pieces of info. The way these questions are set up, they're always going to be set up that the final destination does not have enough information. So you have to start in the other triangle. Why else would I give it to you? Yeah.
Doesn't triangle SDQ technically have all three angles?
Yes. So we could say it's 4 pieces of information. We could. Yeah. Here, how about this? I say 3 plus pieces of info, right? That makes sense. Now, what do we find? We find we could solve the entire triangle, right? But that's a waste of time. What am I going to solve for? In ADS, what's the side I'm going to solve for? Say it out loud. Yeah, opposite or A or X. And the reason is we're gonna solve the one thing that the two triangles share. They share that side. So that's why we're finding it. We're not finding it because the X is there. We're finding it because those two triangles share it. And in order to find why, I need more info. So step 2, solve the common side or angle. What both triangles share. Okay, this is the strategy for all cases where you have two triangles stuck together. And now that I have some information for the second triangle, I can solve for unknown in second triangle. Yeah.
Do you want to spread all this out? Or?
This is not on the quiz.
Oh.
And you do not have to write these steps, but you're going to have to follow them. Yeah. Okay, so let's try this out. Do you need time? Yeah. If I'm going too fast, just say, Miss Lai, stop. I need time to write it down. So if you do have any questions, yeah, coming up. Yeah, if you can just interrupt. Yeah, I know it's there already. No, it's good. Okay. It's good. You're good? Great. Okay, come join class. All right. So I got my step 1. And so because I've got two triangles, I need to communicate in which triangle I'm working. Okay? It's a very sad triangle. Do you get why? Do you get my little joke? It's a sad triangle. SAD. Wah, wah. In triangle ADS. Okay, we're going to solve for X. So, I'll redraw it. You don't have to. ADS. I know that's 90. I know this is 10. And I know this is 35. And that's my X. You can label this like on the given equation. So I'm going to circle the angle I'm using. And based on that angle, label opposite, adjacent, hypotenuse. I'm going to circle the piece of information that I have and the piece that I need to find. And so if I circle O and A, that's my TOA. Aha. So I'll be using tan. So let's set it up. Tan of angle A equals opposite over adjacent. Beautiful. Now let's fill in the values. Go ahead, solve. You can make it into, you can use the T method, or you might recognize that you're just going to multiply both sides by 10. Okay, I'll do the T method. So over 1, and I've got this divided by that. To the nearest tenth of a meter. Which equal sign am I using? Oh yeah, I rounded. Yeah.
Do you have to put the 0.0 or can you just leave S?
Great question. So my calculator says 7.002. And so the question is, can I just write 7 or do I have to write 7.0? Which one of these is more precise? Which one? Yeah.
7.0.
Yes, because this 7 could be 7.1. It could be 6.9. It could be 6.8. Right? Because we don't have that next decimal, we don't know. But this one says, hey, I guarantee you that the first decimal place is a 0. Great. Okay, I'm going back to my game plan. Start with the triangle with 3 pieces. I did that. Solve the common side or angle. I did that. Right? So that was really step 1 and step 2. We're now moving to step 3. Solve unknown in the second triangle. Hey, I'm moving over to the second triangle. So I'm going to let Miss Sly know, hey, now I'm working in triangle DSQ, disqualified. And in that triangle, I want to solve angle Y. I'm going to again redraw it. You do not need to do it. You can label it on this triangle that's given. That's my Y. That's like this. D, S, Q. And now that I have a new piece of information, I can add that 7.0. Yeah.
Do you have to label it on the triangle, or can you just if you give yourself names of angles, can you just go from there?
Like you've labeled it at the beginning of the question?
Do I have to write opposite and adjacent and hypotenuse, or can I just leave it?
Yeah, I don't think you need to.
Okay.
Yeah, if you can do it without doing that, that's fine. Okay, circle the angle we're using. Okay, we're using 48. Label the triangle based on 48. So we've got opposite, hypotenuse, adjacent. I always do adjacent last because I keep forgetting what it means. I circle the information I have. I circle what I need to find. Once again, I see I've got O and A. I'm using TOA. So go ahead and set up an equation with tan 48. And it's opposite over adjacent. And I'll use the T rule, or I'll say, hey, I know they're going to swap. And I get that Y is 7.0 divided by tan 48. On your calculator, 7 versus 7.0 doesn't make a difference. Yeah.
Should we have the dot over equal sign?
Yes, thank you. Yes, folks, your grade 11 teachers are going to be impressed.
But like also in the like equation,
Yep. Oh, thank you. Even here. Tell me why, Oliver.
is the 7 was rounded.
That's right. This 7 is already rounded. So when you're putting these equal signs throughout, you're saying, hey, keep in mind, I'm using information that has already been rounded. Beautiful. I love that. Thank you for the reminder. All right. So we got this. So let's skip over back to page 12. Or is it 16? I don't know. 14. And now we'll follow the same steps for example 1. As you can see, it's a bit trickier because the triangles are on top of each other. So in this case, I might draw both triangles independently. So let's start with ABC. You do not need to redraw, right? If you're able to see it in your head, great. But I want to make sure I understand what's happening. So the smaller one has the angle of 33 degrees. Both of them share 200 meters. Okay, then I've got my bigger triangle. That's A, B, D. That's 200 meters. Now the angle, the acute angle is 42 degrees. So please ask me if you want me to explain again how I got these pictures. Just flash me your hand, say please. Okay. Point with your finger to what I'm trying to find, what I mean ask to find. Is it, am I being asked to find this height? No. So can you talk to the person next to you? How am I going to find this little x? How am I going to find that little side?
That's true.
Okay, what's our game plan going to be? X will equal, right? So I'm looking for this little piece. Yeah.
Could you make like not like make a triangle, but could you do triangle like ABC instead?
That's a great question. All right, so listen up here. So the question is, can I instead just work in triangle ABC? No, you cannot. Can you tell me why, Maya?
Because there's no angle. I don't know.
It's
It's not right angle.
beautiful. I knew you could answer your own question. It's not a right angle triangle. Now, next week, we're going to learn the sine law and the cosine law. And for those, you do not need a right angle triangle. But today, with SOHCAHTOA, those are called primary trig ratios. With the primary trig ratios, you need a right angle triangle. That's why this question is difficult, because we can't use that small triangle. But watch this. To find this little x, all we need to find is say, hey, this big line, this big side, minus this little side, right? Can we find each of them? Yeah, we can. So my game plan is this. To find x, it's going to be side DB subtract CB. That's all I got to do. So I got to work in both triangles. And I'll start in the little one that is purple for me. So I'm looking to find CB. Which triangle am I working in? Oh, I don't like that. This is how I've written it. In triangle ABC, comma, find CB. That makes more sense. So I'm saying, hey, I'm working in ABC, and my goal is to find CB. That's the side between angles C and B. Go ahead and find it, folks. And after you do that, you'll do step 2. In triangle ADB, find DB. And you'll notice you're using the same trig ratio both times. Opposite. If you're stuck, see what I'm doing, ask me a question. Yeah. Oh, that's not a question.
Why is it that the smaller angle is
Yeah. So what am I looking to find? I'm looking to find CB. So that's this side. Okay, that's my opposite side. I'm looking to find the opposite side. So tan of 33 is opposite over adjacent.
No, I knew that. I just didn't know why I was thinking for the smaller triangle and not like the bigger triangle.
Why is the bigger triangle tan 42?
Yeah.
Yeah, good question. So this little arc here, let's make it a bigger color. This little arc says, okay, this 33 is this angle. Got it? And then it says this bigger arc is that angle. So yeah, that's a fair question. Understanding these pictures is like a big part of the question. Yeah, sorry, I kind of glossed over that. Thank you for stopping me. Folks, I'll give you 7 points for that because I really want to encourage you like to go back and be like, hey, how did you get 33 and 42? Because do you know what I did? It was my mistake. I kind of assumed that, like, I just went way too fast in that little piece. So I give points, very important points, when students ask me wonderful questions. Yeah. Are we told how to round here? We're not. What do you think? Nearest 10th? I think 1 decimal is good. Okay, so I'm going 200 times 233, 129, purple, 129.9 meters. It's 180.1 meters. Folks, when I get to this point, so I have 2 measurements. I've got 180.1 and I've got 129.9. I want to use my critical thinking to ask myself, does this make sense? So thumbs up, it makes sense. Thumbs down, it doesn't make sense. Hugo, tell me why it makes sense.
Because the bigger triangle has the larger side length.
Beautiful. Right? That's critical thinking. Just pausing and saying, does it make sense? Instead of just punching something and just taking the answer. What kind of mistake could I make here? What's What's the most common mistake that I could make? Yeah.
Doing CB minus DB instead of DB minus CB.
That's later on. But like, let's say I got an answer like 14 or something, or 0.56. Where would I have been making the mistake? Like probably on my calculator, right? So that's why you want to use your critical thinking to say, does it make sense? Because you might have punched in the wrong number, or maybe you're in radians mode. Yes.
It could be a mistake, like if you don't put the dot in the equals.
Like this mistake?
Yeah.
So that's a good question. That's a communication mistake, right? And in grade 10, I'm not going to be very picky on this, but it's really good for grade 11. But that could be a mistake that you forget. Hey, I rounded. Great. Okay. Now I'm not done, right? Because I might be like, hey, I'm done. But I go back to the question and I'm like, oh, I'm supposed to find X. Yes.
When you're doing like any of the trigonometric ratios, you keep like I noticed you keep the degree sign after every number. If it's
Yep.
tangent 33.
Yep.
It's 33 degrees.
Yep.
Why do you have to keep the degrees?
Yeah, so degrees isn't the same as meters, right? Like if it's 200 meters, I don't write that in the equation. That's a really good question. But I don't know why I keep it. I think it's important communication. Yeah. Sorry. But good observation, and I don't know the answer, but we do it. All right, and so at the beginning we said X is going to be dB minus CB. So what do I get? Well, dB is 180.1. And Alexi's going to say, don't forget to do the equal sign. Was it you, Alexi, that reminded me of that? No, who was it? Oh, it was Oliver. And CB is 129.9. Okay, what do we get, folks? 180.1 minus 129.9. 50.2 meters. This is a ginormous triangle. Just keep in mind. Like if we were to build it, this is like 200 meters tall. Okay? Just keep it in mind. All right. How are we there? We're good? You ready for a harder one? Of course we are, Miss Sly. Good. We're going to do one more example today. And we'll do example 3 tomorrow after the quiz. Okay. So I want you to look at this triangle. What can we for sure draw in there? Yeah, we need to put a right angle in there. How many triangles are we going to be working with? 2. How many triangles are there? 3, that's right. One of them is not a right angle triangle, so we're not working in it, right? We're not going to work inside RQS because we don't yet know what to do with non-right angle triangles. Okay, what I'd like you to do before we even start is think of a game plan. So talk to someone, think on your own. How am I going to find the X?
Okay, so
That's tricky.
okay. What I would do.
This is really important thinking and inquiry stuff. Alex, do you know how to do it? Good. Ooh, I like that. You're thinking in ratios, Cruz. All right, Cruz is thinking some awesome things. He's like, what percentage of this and that? And I'm like, yeah, that's a ratio. Anyone have an idea? Okay, folks, it's kind of hard, right? Because in each of our right triangles, we don't have actually enough information. We don't have one full side for either of them. Like if I were to redraw the bigger triangle, I've got R, Q, T. Oh, I didn't do attendance. I don't know X, but I need to find it. Well, I know this angle, but I don't even know the length of this side, right? I know like part of it is 50, but I don't know the entire length. Then in my other triangle, okay, that's Q, that's T. It also has X. This is S, and that's 46. I only have 2 pieces of information. And in the top triangle, I have like 2.5 pieces. Yeah.
Would you like use like one of the inverses to find another angle?
Good question. Could we find these 2 angles? Easily. Sum of angles. But to find a length, I need to have a length. Okay, so watch this. This is going to be ugly. You're not going to like it. We're going to do it. What side, what measurement should we find? Like in order to find X, what other piece of information do we need?
Either ST or SQ.
Yep. Which one do you think we should find? ST or SQ? Watch here, watch here. So should we find the hypotenuse here? Should we focus on that or should we focus on this ST? Why ST? I agree, but why are we going to say, hey, let's focus on ST? Alina?
You can add, if you find S, you can add S the value of ST and then 50 and then it'll give you like the
Yeah.
bottom line.
Yeah. If you find ST, then you also know the length of the base of the large triangle. So what I'm going to say is, hey, I recognize that ST is important, and I'm going to call it Y. So what did I just do? I introduced another unknown. Show me with your fingers, how many unknowns do I have? Dos. In order to solve for 2 unknowns, how many equations do I need? 2. I'm going to create a system of equations and solve for the 2 variables. That's why it's a thinking question. All right, so let's put the Y into each of these triangles. So in the smaller triangle, the base is just Y. However, in the larger triangle, what do I write? What is the length of RT? Yeah.
Y plus 50.
Great. Y plus 50. Right? Folks, this is good stuff for grade 11. 50 plus Y. That's the entire base. Okay. So Miss Sly just said, create 2 equations and then you can solve for 2 unknowns. So let's start in triangle RQT. Which is the side that we're not using? Opposite, adjacent, or hypotenuse? Hypotenuse. So if I'm not using hypotenuse, is it SOHCAHTOA or TOA? TOA. So if I'm not using hypotenuse, it's going to be tan. So let's write it. Tan of 28 degrees, right? I'm in the big triangle. It's opposite over hypotenuse. Well, the opposite from 28 is the X.
Isn't it off over edge, like opposite over adjacent, not on the bottom?
Ugh. I'm just saying things. Gosh. Yes, it's opposite over adjacent. Okay, so 28. Opposite over adjacent. Well, what's adjacent? Ew. Really, Miss Sly? You're going to make us write Y plus 50 in the denominator? Yep. It's ugly. We're going to do it. Okay, let's keep it at that because I don't know what form I need to do. I don't know if I need to isolate anything. So then let's move to the next triangle. And we'll also write a statement for tan. Tan of 46 degrees is opposite over adjacent. Okay, so I get opposite over adjacent. And I can isolate x, right? So if I multiply both sides by y, these two y's cancel out, and I get that x equals y times tan 46. Right, this is next level, folks. This is hard math. Okay, so just bear with me. Now I could substitute, I'm going to call this equation 1. I could substitute it into the orange equation, but the orange equation still looks a bit messy. So in the orange equation, I want to isolate x. So I'm going to multiply both sides by y plus 50 so that I can cancel those out. So x equals y plus 50 times tan 28 degrees.
Does it matter if you put tan first or after?
Nope, they're multiplying each other. You also could have said, hey, I would have preferred to isolate for y. Cool, right? In this case, there's so many ways to solve these two equations. Okay, so now I see that the orange equation has an x and the green equation has an x. So I can say that equation 2 equals equation 1, right? Because the x equals the x. So let's write it out. So I'm not going to, well, I guess we could write x. Here, I'm going to make it color coded. X equals x. And as a result, the other side equals the other side. So I've got y plus 50 times tan 28 equals y times tan 46. Oops, that's supposed to be green. I'm stuck. I don't know what to do. What's something I could do? Like in this moment, it's like, just try something. So look at the orange part. What could I do? Yeah. I could, but I'm going to have a bunch of decimals. So let's keep it as tan 28. That is definitely a good thing. Yeah. I can expand it. Watch, folks. I can expand. I can go this times that and that times that. So ugly. I know. It really is. So I'm going to have y times tan 28 plus 50 times tan 28 equals y times tan 46. I want to isolate y. So I'm going to bring all the terms that have a y to the right side. So this term stays. 50 times tan 28. And I'm like, oh my God, I can evaluate that. That's just numbers. On the right side, I've got tan, y times tan 46. And what happens to the orange one? Becomes minus y times tan 28. We're getting closer. And now we go back and do that horrible factoring that we hate. Why did she say the F word? We're doing trigonometry. Factoring should not come into play. What kind of factoring am I going to do? What is it? What is it? Come on, say it. Do you know it, Quincy? You're like, you don't want to say it? What if I give you 1,000,000 points? Yeah, take it. I'm going to dare you. Just take a stab. I think that's a really good idea. What kind of factoring is it when you factor out the y? What do we call that? Greatest common factor or just common factor. Okay, I'm going to give you 50 points, not because you were right, because you took a stab at it, right? Because you took a risk. Okay, so I want to congratulate you on that. So we're going to factor out the y. Interesting. And the benefit of that is, hey, now I can evaluate, I can find a number for the stuff in the bracket. And I want to be really fancy. So I'm going to divide both sides by this tan bracket. You probably are like, I just want to put it in my calculator. Cool, no problem. But I do like to leave the calculation until the end so that I can really show what I'm doing. Like if I put a number, if I put like a decimal there, people would say, Miss Lai, where'd you get that from? Right? Since the numerator and denominator has the same factor, I can cancel them. Who's liking this question? No. Anyone? Are you liking it? No? Anyone? Come on, it's kind of a mind bender. All right. Can you do that whole thing in your calculator in one go? So let's protect the numerator with brackets. Let's protect the denominator. Well, the denominator already has brackets. Okay, that's just a fair, that's good practice. So let's see if we can all get the same answer. Yeah.
Wouldn't you take the tan 28 out of both fractions because it's on the top and it's on the bottom?
Yeah, so you can't.
Oh.
Because the denominator is not factored, these are two terms that are being subtracted. If they were being multiplied, you could cancel them out. It's like this. If I have x times y over x plus y, I cannot cancel the y's. Does that make sense?
Like, no, but I'll go with it.
Well, then watch this. If x is 2 and y is 4, and I'm like, hey, I can cancel out the 2's, that becomes a 1. I can cancel out the 4's, that becomes a 1. Okay, I'm going to get 1 over 2, I guess. Versus if I have 2 times 4, that's 8. 2 plus 4, that's 6. These two are not the same.
Okay.
So all that means right now is you can't do it. Okay? That is actually a very common mistake in grade 11. They really want to cancel out the factors. Okay, so we're all taking our calculators and doing this big thing. You might have to add an extra bracket. Okay, I get a number. 26.154, so I'm going to round it to 26.2. Let's see. I'm just saying what I got. And I'm going to put approximate, and then I'm going to say, does that make sense? For y. Anyone got similar? Okay, so try again. Make sure you're putting brackets. Did you try brackets? Yeah. Yeah.
Are you supposed to put brackets around the 10, 28? That's also.
This one?
Yeah.
No,
Like
because
in your calculator.
no, but this is what happens, folks. This is what sometimes happens. Your calculator opens up a bracket. Like if you press tan, your calculator naturally opens a bracket. So you might have to close it. And then you might have to do a second one. Try again. And if you didn't get it, bring your calculator to me. And if you did get this, go ahead and find x. Because that's just the y. That's not even what we're supposed to find. And to find x, I'm going to use the easier looking equation, equation 1, where x equals y times tan 46. You're like, I can't believe I have to do linear systems again and factoring. In the last unit of trig, why, Miss Sly, why? If you didn't get 26.2, please bring your calculator to me because I can check or problem solve. It's just a calculation error. And you just need to learn how to use your calc. Yeah, come on up. You got 25.2? That's very
I got 25 too.
I got
52.
okay. Maybe I made a mistake.
Okay, I guess we do different brackets.
I added two brackets around the bottom one. And then
I put brackets.
I added too many brackets around.
Yeah,
and
if
then
you
it
take
gave
the
me
brackets
52.
off the bottom one, it works out.
Oh, it does.
But to 25.
50 times tan 28 equals divided by open bracket tan 46. There I am, assuming I got it right. Goodness gracious. Minus tan 28. I got 52.
Wait, so when you put the
That's what I
bracket,
got
you get
first.
52. But then when you take the bottom bracket off, you get 25.
Yeah.
Yeah, because
I got
if you
52
take the
also.
I got
that
52,
does, 50 times 10, 28 times 26, and then that minus 10.
So which one do you think it
I
is?
think it's
I think
52.
I think it's 52.
52?
It looks
I
like
was
proportional.
right.
Oliver, do you think it's 52?
Yeah.
Okay, how many people think it's 52? Then we're doing 52. That's just how you do math, right?
Just choose the answer.
Just choose what everyone likes. 52.8. Oh my gosh. Everyone was right. Miss Sly was wrong. 52.8 times 10, 46, close bracket. And so we get 50. Yeah, this makes sense. That x is approximately 54.7 meters. Yeah, thank you. I got the thumbs up of like, I agree. And I know this one is close because if the angle is 46, it's got to be very similar. Wow. So that was a whopper. Can this show up on a test? Absolutely. Level 4, don't sweat it. I'll give an option for level 3. But if you want to challenge yourself, and so tomorrow we're going to do something very similar. We're going to do example 3 together. And that's going to require us, again, to make a system of equations. Yeah. Folks, you can do this. All right, well done. Well done.